Okay, we're on part 2 of chapter 10's Voyage Through Algebra. Again, this should be stuff that you've seen before, but we're going to do something new with it. This is solving quadratics with factorising. Okay, so without thinking, just come up with two numbers in your head that times and give you the answer of 0. Okay, time's up. I came up with 9 times 0, but you could have come up with 0 times 3, or 1,000 times 0, or I guess 0 times 0. The whole point is that if you want to get an answer of 0 when you multiply, you need to have one of the numbers be 0, and that's the fact that we're going to be using. So here's some algebraic questions which are asking the same sort of thing. We have got a bracket here, and we have got a bracket here, and because they're next to each other, algebraically that means they're being multiplied by each other. So we are multiplying the bracket x minus 3 by the bracket x minus 2 and getting the answer 0. Now if that is true, that means either this is 0 or this is 0, because how else could they multiply and give you 0? So the way we actually solve these is we split it into two possibilities. Either x minus 3, this bracket, is 0, or potentially the other one might be true, x minus 2 might be equal to 0. And all we have to do from then is just solve those separately. So if x minus 3 is 0, that must mean that x is 3. If x minus 2 is 0, then x must be 2. So if we were given something algebraically like that, that's how we'd solve it. What about if we tried to apply it to the second question here? We're going to again split it down the center. Well, either x plus 5 is 0, in which case x is minus 5, or x plus 4 is 0, in which case x equals minus 4. Hopefully you're beginning to notice a little bit of a shortcut way of doing this now, which is that if this says minus 3, then we just change the sign and say x is 3. If this says plus 5, then we just change the sign and say x is minus 5. But we'll proceed a little bit further. What about this one here? Well, if you've just got x on its own, that's x multiplied by x minus 6. So either x equals 0, which is dead easy to solve because it's already solved, or x minus 6 is 0, so x is 6. So we end up with these sort of sets of two solutions, and this is the general idea for solving a quadratic equation with factorising. We're going to put things into brackets, and we're going to use this sort of zero multiplication fact. So what about if they were a bit more complicated? What about if we had not just x, we had 3x? Well, we can still do it the same sort of way. We can still take this factor here. We can say, okay, so 3x minus 6 must be 0. Now that would mean 3x is equal to 6, and so x would be equal to 2. We just add the 6 and divide by 3. Whereas this x minus 5 equals 0, 1 is just going to give us x equals 5. There's our two solutions there. What about here? We'd say 2x minus 5 is 0, or x plus 5 is 0. We'd say 2x is 5, so x is 2.5, or x equals minus 5. Okay, fair enough. And then what about this last tricky looking customer? Well, we'll end up with either 7x plus 4 is 0, in which case take away the 4, divide by 7, x is minus 4/7. Feel free to leave it as a fraction, by the way. That is a horrible decimal and we don't need to see that. Or the other one, 9x minus 1 is 0, so 9x is 1, so x is 1/9. So that's the first thing that we have to get on board. If we've got these two brackets being times together and giving an answer of 0, then we can just solve each of those brackets separately being equal to 0. And hopefully you've noticed that sort of shortcut we had there, which is that to get what x is, you just change the sign in the bracket and then divide by the number of x. So for example, if I wanted to get this 2.5 here, change the sign so this minus 5 becomes a plus 5, and then a divide by the number of x. Now that shortcut obviously works, but it's important to know why it works, so I wouldn't want that to be the main way you to do these. Okay, so I'd like you to have a go. Pause the video here. I'm not going anywhere. I'll come back in 5, 3, 2, 1. Okay, so the first row of these is okay, although I did try and throw in a few little curveballs. Again, we've always got something times something is 0. So our first step should always be to set each of those brackets equal to 0. and then it's just a case of making them just x on their own. So our first solution should be minus 7 and 3. Now the second one, remember, if we've just got an x on its own, then we just say x is 0 and we're done. If we've got 2x plus 9 is 0, then 2x is minus 9, so x is, you could say minus 9 over 2. I'm going to say minus 4.5 though. What about this sort of monstrous customer here? Well, we can still do the same thing. One of these has got to be equal to 0, so we're going to have 4 solutions rather than 2. This is actually a quartic equation, which, to be honest, you're probably not going to get asked in GCSE, but the principle is exactly the same. You take each of the brackets, you set them equal to 0, and then you solve the bracket. So it's just add 3 there, just take away 7 there. It would be add 3 and then divide by 10, and it would be take away 1 there. So your solutions would be 3, minus 7, 0.3, and minus 1. Okay, great. What about this one? Well, we're saying if something squared is 0, I suppose realistically we could sort of square root both sides and just sort of say, so x plus 5 equals 0. But probably going forward, a better way to think about this is, remember that if you've got a square by a bracket, it means that bracket happens twice. So this is really saying x plus 5 times x plus 5 is 0. So either x plus 5 equals 0, and so x equals minus 5, or x plus 5 equals 0, and we get the exact same solution. So yeah, x is minus 5 in that case. Kind of do the same thing here. We'll end up with just x minus 3 is 0, so x is 3 is our only solution here. And then for this one, you are going to get a potential solution from the x, and you're going to get a potential solution from the x minus 2 bracket. Interested how you did on that second row, actually. There are a few interesting questions there. So that's kind of like the new bit, but before we can actually go ahead and use that to solve quadratics all in one go, we kind of need to remind ourselves of factorising as well. And there's 3 sort of levels, I suppose, of factorising that we've gone through this year, mainly in chapter 6 if you want to go back to your notes. And the simplest one was if we just start with a single x squared. That's the old add and times. So we add to the number of x, which in this case is 7, and we times to the n number, which is 10. So you think, okay, well, what adds to 7 and timeses to 10? And you have to go through the numbers, and you think, well, okay, the only numbers that that's true for is 5 and 2. And then a lovely little shortcut we could use with these sort of simple setups is that those are our brackets. So that factorizes just to x plus 5, x plus 2. Job done. What about this one here? Well, we want to add, wrong way around. We want to add to, and remember the sign, minus 8, and we want to times to 12. So the numbers that would do that, after a little bit of thinking, are minus 6 and minus 2. If you want to times and get a positive, they're either both negative or both positive. And so our factorising would be x minus 6 and x minus 2. What about the third one? I guess I'd like you to try the next 3 yourself first, but I'm going to assume you've paused and tried it. We'd want to add to 7, and we want to times to minus 30, and the numbers that do that. So because they times to a negative, you know, one's positive and one's negative, so you're kind of thinking it's a sort of a subtraction sum that gives you the 7, and the answers are going to be 10 and minus 3. Now, if you couldn't think about those, you'd have to go ahead and just write down the things that times to 30 and sort of go through the list of things that might get you to 7. So looking at that, the 3 and the 10 are the only thing that's going to get us there. But I assume we've just seen it. Once we've got that, we've got a 10, we've got a minus 3, we are factorized. Great. Okay, what about these last two? So this one is a special one called the difference of two squares. Oop, can't spell. Squares. And the special thing about this is there is no x in the middle. You could write this out as like x squared plus 0x minus 25, I suppose. And so what we actually want to do is we want to add to 0, and we want to times to minus 25. Now if we want to add to 0, the numbers have got to be sort of positive and negative of each other. So it's actually going to be 5 and minus 5 that do that. However, you can sort of just recognize this is happening, that there's no number in the middle. You know it's going to be plus and minus the same number, and it's got to times the 25, so it must be 5 and minus 5. Either way. And in our last one, we have no number at the end, and people tend to go a bit mad on these once they've got used to the earlier types. We can still think about it in the add and multiply way. We can still say, okay, what adds to 8 and times is to 0? And we know that by now that means one of the numbers must be 0, and if they add to 8, it must be 8 and 0. So we could go ahead and write down x plus 8. Let me write this the other way around. We could go ahead and write x plus 0 and x plus 8, but that's a bit horrible. What we tend to want to do on this sort of question is actually just recognize the fact that this is a simple factorizing. You can fit x into both terms, so it's just x plus 8, which is how you'll normally see this done. Okay, that's part 1. But there's also some tougher factorizing as well. There's some harder quadratic factorizing. And there's 2 ways of doing these, and I did want to treat these as 2, I suppose, separate methods, because I think they'll appeal to 2 different types of people, but it's useful to know about both of them. So let's look at our first one. When we start with more than 1x squared and we reckon we can guess it, that means the numbers are ones that are fairly straightforward to break down. So we write down our 2 brackets. So here's our brackets. The first term has to multiply the number of x squared. So these 2 terms here are going to have to multiply to 3x squared. And there's only really 2 things that'll do that, which will be 3x and x. Now if it was like a 6x squared, we'd have to think about it a little bit, but we're good. 3x squared, 3x times x. Okay, the second term in each one has to multiply to the n number. So we need to find 2 numbers that multiply to 2. And well, they're going to be 1 and 2. And the third step is going to be to fiddle around with possible configurations until the middle bit works, which is a little bit of less scientific way of saying do a bit of trial and error. So we know this is 1 and 2 in some order. So let's try putting them in this way around. How do we check it works? Well, we expand it. We multiply out that bracket. And if we do that, we'll get 3x squared plus 3x plus 2x plus 2. We'd get 3x squared plus 5x plus 2. But that is not what we actually want. We want 7x. So that must be wrong. So we try again. And we go, okay, well maybe it isn't 1 and 2 that way around. Maybe it's 1 and 2 that way around. Expand it. 3x squared plus 6x plus 1x plus 2. And yeah, that would simplify to 3x squared plus 7x plus 2. You'll note kind of like the only important bit is here. So you can sort of do it in a cheap way by just considering that and that being added together. But either way, you've got to do some sort of check at the end. You can't just assume it's 1 and 2. Okay, let's just have a look at a couple more examples of the same thing. We've got 2x squared minus 5x minus 12. So put down my 2 brackets. I know this is 2x and x. And then there's quite a few options for what 12 could multiply to. It could be 1 and 12. It could be 2 and 6. It could be 3 and 4. There's lots of options there. So you'd maybe start trying some out. Now, if you know the middle, it's got to add up to like 5. I think 1 and 12 is probably out of the question, so I'm going to try that last. Let's start with 3 and 4. And numbers that are relatively close to each other. And let's try minus 4 plus 3. So if we expanded that, and again, remember it's only really this bit we're interested in, minus 4x plus 6x will give us minus 2x. No, that wouldn't work. Okay, what about then if we had the other way around? What about if we had plus 4 and minus 3? Well, we could try it again. That would give us 4x minus 6x. That would give us minus 2x. No, we want minus 5x. Okay, that doesn't work. What about if we switched these around a bit and had 2x plus 3 and x minus 4. That will give us 3x, that will give us minus 8x, and yeah, that adds up to minus 5x, so that must be our factorising. Now you can see the downside of this method, that you have to be very good, very intuitive at spotting these sort of number patterns. It does get better with practice, it's stuff you can do in your head rather than have to write down, but that's the drawback here. It is super quick if you can spot it though. Last one, this is another difference of two squares. And that means that our brackets are going to be the same thing, so it's got to be 3x and 3x to get to 9x squared, plus or minus the same thing. It's got to be 9 and 9 to get to 81. Dead easy if you can spot a difference of two squares, look out for them. And then the other way that we did these was we used this whole multiply, add, multiply method. So I called this the MAM, I think. So it starts by like writing these numbers, or these letters, sorry, on the top. And what we do is the two things that have got M on them, we multiply them together. So we need to times 2, 3 times 2, we need to times to 6. We need to add to the middle number to 7. And the numbers that do that are 6 and 1. And it's so far, it's quite similar to the first method we looked at, but there is a little bit more of a subtlety to it, in that you don't have the bracket straight away. You need to use those numbers to split the middle up. So we're going to have 3x squared plus 6x plus 1x, which we're getting from up here, and then still plus 2 on the end. And then we've got our last step, factorise each half, then bring the brackets back together. So by each half, I sort of mean like if we draw a dotted line in there. Factorise what goes into 3x squared and 6x, 3x, lots of x plus 2 there. What goes into these? Nothing, just 1, so 1, lot of x plus 2. If you've done it right, then these two brackets here will be the same thing. They're both x plus 2, so we know we're okay. So our final step is to collect our brackets together. So we're going to take the 3x that's here, we're going to take the 1 that's here, and we're going to say that's 3x plus 1, and we're going to take the x plus 2 bracket and say that's x plus 2. So yeah, that's the MAM method. I will go through it on the other two, but I'm not going to talk through it. So if you want to pause here, have a go at those last two, and then unpause when you're ready. In 3, 2, and 1. So there's the first one. Nothing particularly special about it, I guess. Should end up with 2x plus 3x minus 4. Okay, have a go at the second one. I'll see you on the other side of the pause. And there we go. So benefit of the MAM method is that it always works, but the downside is it might take a little bit more working than the previous method we looked at. I don't mind if you want to use this exclusively or the previous one exclusively, as again we've discussed at length in chapter 6, but make sure you've got one of those that you're happy with. Okay, so we're now going to put all of this together. We're going to look at solving quadratics with factorising. So here's what we've got to do. First thing, our equation needs to be equal to 0. That's not going to be a problem on this page. Second thing, we need to essentially factorise. We need to find some brackets that make it work, and you can use either of those last three methods we just looked at. And then the third thing we need to do is to set each bracket equal to 0 and use it to solve x, like we did on the first couple of slides. Normally, we'll get two values, but not always. Okay, so let's see if we can apply this to this first one. This is a simple one where we want to add to minus 6, we want to times to 8, and the numbers that do that are minus 4 and minus 2. So we factorised it, and now we've got two brackets with times together to give 0. So that means either x minus 4 is 0 or x minus 2 is 0. And so our solutions are x equals 4 and x equals 2. And that's it. So it's factorising with an extra step. That's all it really boils down to. What about our second one here? This is a bit more complicated. I am going to use method 2 with this one, which is the old have a bit of a guess system. I know these have got to be 2x and x. I know that the other brackets could be 2 and 2 or 4 and 1, but if I want to get an answer of 7, I probably need an odd number in there somewhere, so I'm going to try 4 and 1. One of them is going to have to be negative, so let's try minus 4 plus 1. See if that works. We get minus 4x plus 2x. No, that would give me minus 2x, so it's not that. So what about if we switch those two around? What about if we say plus 1 and minus 4? That would give me plus 1x minus 8x. Yeah, that equals minus 7x. So there is our factorising. And then we do the same thing. We set each bracket equal to 0. Now x minus 4 is 0. That's easy. X equals 4. Just move the 4 across. For the other one, we need to subtract the 1 and then divide by 2. Now you could say minus 0.5 if you like. I'm going to probably switch over to some fractions now. And then I thought I'd do the last one using like the MAM method because it's quite a good candidate for it. We would need to times to 5 times 3, so times to 15. We'd need to add to 16, and the numbers that do that are 15 and 1, I think. So we'll split it up, 5x squared, 15x, and x and 3. Don't forget this equals 0 on the end, by the way, it doesn't go away. We'll factorise each half, so that'll be 5x, lots of x plus 3, plus 1, lot of x plus 3. And we know we've done that right because we've got an x plus 3 on both sides. And then we bring them together. So we've got 5x plus 1, x plus 3 equals 0. And then we still need to solve it. So 5x plus 1 equals 0, or x plus 3 equals 0. 5x equals minus 1, so x equals minus 1/5. Just about fit it on the page there. Or x equals minus 3. Now there is one last thing to bear in mind here, which is that you do need that whole first point of make the equation equals 0. Otherwise we can't use that little trick of saying, well, one of these brackets has to be 0 because they're just multiplying to something else. Just want to use these as an example of how that works, I suppose. So for our first one, what we need to do is just rearrange to put everything on the left-hand side. So we are going to subtract 3x from both sides, and we are going to add 11 to both sides, and that will give us x squared plus 5x minus 24 equals 0. And then that's a simple add to 5 times to 24 situation because we've just got a single x squared, which would be 8 and minus 3. I think we had those on the previous page actually. And we'll end up with x is minus 8 and x is 3. Fair enough. What about something slightly more complicated looking like this? Well, you might be tempted to start setting this equal to 0, but we can't because this side is not 0. This whole thing on the right needs to move across to the left, but also we need to expand out these brackets, so let's do that. That'll give us 3x squared. Let me see, we'll get plus 4x minus 3x minus 9x either, so that's minus 5x minus 12 is equal to x squared plus 8x minus 5. Then we'll have to move it across, so we'll have to take away x squared from both sides. We'll have to take away 8x from both sides, and we'll have to add 5 to both sides. So we'll end up with 2x squared minus 13x minus 7 is equal to 0, and then we need to factorise it. Now I will skip ahead to the point where I've figured this one out. It's going to be 2x and x, I know that much. It's going to be 7 and 1 to get to 7, and we have to have it that way around. So we'd have 2x minus 7 equals 0, or x plus 1 equals 0. That will give us 2x is 7, or x is 3.5, and x is minus 1 as our solutions. So yeah, if one side isn't 0, you need to make it 0. Now I thought I'd finish off here by looking at 3 applications of this process. So far I haven't really introduced that much new, and this is kind of more of the same. You know, you've seen area before, you've seen Pythagoras, you've seen tree diagrams before. This is just now how can we use quadratics with them. So the first thing we've got an area of 10. So that means that the base times the height is equal to 10. So let's do that. Our base is x minus 5. our height is x plus 4, and they equal 10. Well, let's expand this, because we can't solve it straight away, because this side isn't equal to 0. So x squared minus 5x plus 4x minus 20 equals 10. And then we need everything on one side, so we're going to need to subtract 10 from both sides, which will give us x squared minus x, from putting those two things together, minus 30 is 0. Okay, so step 1, one side's equal to 0. Step 2, factorize it, and this will go to an x minus 6, x plus 5. We need to add to minus 1 here, so the numbers are very close to each other, and times to minus 30. Then we set each bracket equal to 0. And then we solve each bracket. So we've got x equals 6 and x equals minus 5. Now, it says to find x. It doesn't say to find all the possible values of x. And it says we need to find a perimeter at the end of all this. So one of those is right and one of those is wrong. Now, in general, if it's a shape question, the positive answer is right. Because think about if x was minus 5. If we substituted that back into the width, for example, if we said x was minus 5, that would be saying this length is minus 10, which doesn't make any sense. So what we've got here in minus 5 is a solution that works for the algebra, but doesn't work for the actual reality of the situation. Whereas if we had 6, that would work. It would tell us that this length here was 10, and this length here was 1. 6 plus 4 and 6 minus 5. Definitely not to scale that diagram. Anyway, so we'd end up with our perimeter being just the 10 plus the 1 plus the 10 plus the 1. And so our final answer would be 22. We've got centimeters squared in the original question, so 22 centimeters squared. So yeah, it's worth saying in a real life context question, the positive x value is nearly always the one they want you to go with. So yeah, we've done Pythagoras quite recently, probably worth having a go first. Okay, so I'm going to assume you've done that. Now for Pythagoras, because it says it's a right angled triangle, we have one rule, which is that side squared plus side squared equals height squared, or a squared plus b squared equals c squared. Our hypotenuse is the x plus 8, so that's what we're going to have to use there. And our sides are x and x plus 7. So we'll end up with this fine looking equation. Now if we wanted to solve this, we need one side to be equal to 0, so we need to expand things. And just be really careful when you've got a square on a bracket, that means that you have that bracket written down twice. So we do that. And then we're going to need to expand those brackets. So this one will be, once we've expanded it, 14x plus 49. And this one will be 16x plus 64. Then we're going to need to make one side equal to 0. So we're going to need to take away x squared. We're going to need to take away 16x. And we're going to need to take away 64. So we'll end up with just a single x squared left over, because those two will cancel out. Minus 2x minus 15 equals 0. And that is something we can factorize. We need to times to minus 2, add to minus 15. And those numbers are minus 5 and 3. And then we need to solve each bracket, and we'll end up with x is 5 and x is minus 3. Now which one of those is correct? Well, it's a shape. If it was minus 3, we'd have this length being negative, which doesn't make any sense. So our correct solution must be x equals 5. If we substitute that in, we'll show we've got 5, 12 and 13. The area, which is what we actually want, is a half times base times height, so it's a half times 5 times 12, which is going to give us 30. Doesn't really give us a unit, so I'll just say 30 units squared. Okay, got one more to go. Tree diagrams next. Now we had a question quite like this a few homeworks ago, where I think most people's method was a sort of trial and error approach. So I want to show you the quadratic way of solving it. Because we're talking about those sort of grade 8, grade 9 questions, they really love to introduce quadratics with the tree diagrams. Okay, so we've got a bag of 10 marbles without replacement, so stuff's going to reduce. And the probability both are red are 1 in 15, but we don't know how many reds and greens there are. And we want to find out how many greens there were. So what I'm going to do is I'm going to say that there are x red marbles in the bag, and if there are a total of 10, there must be 10 minus x green marbles. We don't know exactly how many, but we can sort of set that as a variable we're going to use. Then we go ahead and we draw our tree diagram. So we're either going to get a red marble or we're going to get a green marble. And we're taking 2 out of them, so that's going to happen again. We're either going to get red or we're going to get green. Now the bit that we have information for is this 1/15. So I'm going to focus in on that branch. That's this one here, isn't it? Red, red. Maybe we just need to work that bit out. Maybe we don't need to fill in the whole of the tree diagram. So what's the probability that we pick a red marble out of there? Well, we said there were x red marbles, so that'd be just x out of 10. What about the probability we pick another red marble? Well, there'll be 1 less marble, so we're now down to x minus 1, but also we're out of 9. So if we know this is equal to 1/15, and we know we multiply along the branches, we can say x over 10 times x minus 1 over 9 is equal to 1/15. Okay, great. So that's what we need to solve. What's an easy way of doing this? Well, we could try and put them together, I suppose. We could try and combine these, and we can sort of do that in a very rough and ready fashion by multiplying the tops by the tops and the bottoms by the bottoms. So if we times x by x, we'll get x squared. And if we times x by minus 1, we'll get minus x. And we're saying that's equal to 1/15. Now, it'll be easier if this number on the bottom was 90. What's 1/15 in terms of 90ths? Well, 15 goes into 96 times. So that would be the same as 6 out of 90. And the reason we do this is, number one, we could cross multiply at this point. But we can actually say, even better than that, that, well, if they're both 90 on the bottom, then the tops must be the same as well. So we can simplify things to just saying, okay, so x squared minus x equals 6. And we can take away 6 from both sides, and we can get to x squared minus x minus 6 equals 0. And at that point, we're happy. We're happy because we have a quadratic, one side is equal to 0, so all we need to do is factorize it. And again, it's a simple one, so we're going to need to add to minus 1 and times to 6. To minus 6 rather. And the numbers that do that are minus 3 and 2. So we can put them into brackets, x minus 3, x plus 2. And then we can set each bracket equal to 0. So x minus 3 equals 0 or x plus 2 equals 0. Gives us our solutions are 3 or minus 2. So that means there are either, if we think back when we said x was the number of red marbles, there's either 3 red marbles or there are minus 2 red marbles. Which one do you think is sensible? Yeah, I think it's a 3. There we go. Some difficult questions in there, but the general idea of factorizing to solve quadratics hopefully makes sense. Cheers.